This is our FurnXpert Reheat application software. Here you can analyze any type of reheat furnaces, continuous type, of course. The two options that are available in this particular one is continuous reheat furnace walking beam and continuous reheat furnace pusher furnace. Of course, you can also analyze rotary hearth furnace, but that's a different application that is not included in this one. So in order to run this software, you can create your own data and create a file out of that, or you can use an existing data that has been created earlier. So the way to do that is either you can do a new, where you can completely start with a new furnace, or you can create or open a new one, which I have done, and this is a new furnace that I've been working with, sample 1-1, whatever is the name. So I've already loaded that particular file, so I don't have to do it again. So let's go to the first screen, which is the furnace data screen. In the furnace data screen, it starts with the furnace details. Furnace detail constitute furnace type. It could be walking beam or pusher, and also the heating type, which could be either a top and bottom fired furnace or a top fired furnace only. Then you can select number of zones for both top and bottom. And then comes the length of the furnace, width of the furnace. And then as this item says here, door areas, there is charge door areas, discharge door areas. You can also have inputs which you can initiate, which are charge roll, slots, discharge rolls, and screen inputs. In this particular application, or in this particular run, we are not going to use it, so we are going to turn them off. The last but not the least is the zone length. And individual zone length starts with unfired zone, and the heat zone 1, 2, 3, as many zones as you have. The last zone is, of course, the soak zone. Here we are saying it's the heat zone number 2. The next set of inputs are wall and skid details. Here you input the area of the walls, both top and bottom, and you select the refractory layers for each of these items, like the refractory of the roof, refractory of the sides, refractory of the hearth. There are 4 different layers that you can work with. And if you click on this, you'll get the list of refractories that's already there in the database. You can create new data, which I'm going to show later on. Then comes this skid installation and skid areas. Similar, just like the refractory of the walls, you have to select the refractory of the skids. The skids consist of skids, the riser, and the crossovers. Then you provide the dimension of the skids, which is primarily their diameter, and also the coverage, which tells you exactly how much of refractory is there on your skid. And refractory factor is the amount of refractory that's existing in your existing furnace. A new furnace would be 1.0, and an old furnace will be closer to 0. The next item is fuel. There are 2 ways you can enter fuel data. One is a single input. That means it's the same fuel and same burners throughout the furnace. Or you can use multiple inputs. When you do the multiple inputs, these items will open right here, and you can fill them up based on each zone. The Fuel types are either gas or oil. The burner types are either conventional, regenerative, or oxy-fuel. With regenerative burners, you have to enter the fuel extraction percentage, and then with oxygen is the pure odor percentage. Then finally, you have to enter or select the gas or fuel that you're going to use. We have this list, and again, you can create your own data in the database. Then the other important parameters for the fuel are combustion air temperature. This is the temperature of the air that comes out of the recuperator if you have one. Otherwise, it's an ambient air. Then the fuel temperature, which is ambient mostly. And then the excess air, we are using 15%. Usually the excess air varies from 5 to 20%. So this is the first data set related to the furnace. The next data is the charge data. And then charge data consists of the charge or the billets, bloom, whatever that you'll be heating inside the furnace. This is the rectangular bar. You have the option to select either circular bar, rectangular bar, slabs, or pipes. And based on each of them, the dimension will be asked. There is always the length of the billets or the slabs that you have to enter, along with this the thickness and the width for a rectangular parallelepiped. If it is a circular cylinder or pipe, then you have to enter the diameter of those. The center-to-center distance is the separation of each billets or blooms as it moves along inside the furnace. Here it is 20 centimeters. That means if the width of the furnace, width of the slab is, or width of the billet is 17 centimeters, the gap between each billet is 3 centimeters. Then comes the charge temperature, target temperature, and delta T. And finally, you have to select the grades of steel. We have got 26 grades of steel that has already been pre-programmed into this particular software. Next is the boundary condition, the view factor for zone 1, zone 2, and the preheat zone, or as many number of zones that will be working. And then the velocity of the gas. So these inputs are for both top and bottom of the furnace. The next is the set points. One of the key things in set points is production rate. We are using 60 metric tons per hour. And you don't have to fill this up, the velocity, which is automatically calculated. The thing that you have to enter is the set points. The set points for the heat zone, or add many number of fired zone there, you'll have to enter their set points. Once you enter the set points and you do a select and profile, it will come and make the profile for you. The profiles are nothing but distance temperature data throughout the furnace length. With this, you are pretty much set to run the furnace. You have entered all the data. So all you have to do, very simple, go and do a calculate. Once you do a calculate, it goes through the iteration. There are 7 iterations, and then finally it comes with the results. The results, if you see, have the part temperature as it goes through the furnace, the center, the top, and the bottom. And of course, like, this is the furnace temperature that was used from the profile. This is the unfired zone profile, which is automatically calculated. And also based on that, the flue gas temperature is determined. So the other data that comes from here is the heat profile. The heat profile is the profile of heat that is required to run the furnace at that production rate with that billet. So if you notice, like, it starts slow and then it goes high up and then it comes down again. So the next thing is, or the next tab is the zone heat. Here, for each zone, you get to see heat to the part, refractory losses, slot losses, charge door loss, discharge door losses, heat to the rolls, and total heat demanded. So it works for both top and bottom of the furnace. So the next tab is the amount of fuel or the combustion analysis based on your heat demand. So it starts with the available heat on the top, and then the next item is recuperated heat. If you have a recuperator, heat to the fuel, flue loss, net heat required, and the gross heat required. So again, it works for both top and bottom zones. The final results constitute the total availability or heat demand, part to the heat, wall loss, door loss, slot loss, skid loss, heat to the rolls. Then comes your other heat, which is heat to the air, heat to the fuel, and the heat input. So this is the most important thing, like, based on this particular furnace at that production rate, you need this amount of heat to run the furnace. Flue gas temperature is 720 degrees C. This is the flue loss, flue sensible, flue total, and fuel consumption. So this is the heat balance. And at the bottom, you get the fuel flow, airflow for both top and bottom zones. In addition, you also get percentage of loss due to scale, weight of steel loss to scale, scale heat of formation, and scale sensible heat. So this is the final results from the analysis. Then comes the report. There are several reports that are being generated. The first report is the input as well as temperature profile of the part. The next report is all the heat related information for both top and bottom zones. The next thing that I'm going to show you, the 2D profile. Now, if you go to the charge data, you notice, like, there is a skid mark. If you use the skid mark here, so I'll use a default value, select them, and then skid analysis, I've turned it on, so it will do the skid analysis. So let's go to the charge profile, and we will run the 2D analysis right here. So the 2D analysis is using the boundary condition on the temperature of the furnace and using it to run the thermal analysis of the slab or the part in 2D. Once the two-dimensional analysis is complete, we'll be able to go to the 2D profile right here and would be able to see the temperature dether of the part at any point inside the furnace. So the first one is around 8.198 meters. And let's see what is the temperature of billet. Like, if you notice, like, there's a cold points right here in the center due to skids at these 2 points. And the hottest points are, of course, at the corners. So this says the total node temperature, the nodal temperature and dether at a furnace distance of 8.12 meters after 71.18 minutes from the charging end. So you can see the profile at any point. So if you go right here, you can see the temperature profile. So it's pretty much soaked, only 3 degrees Celsius difference between the hottest and the coldest part. Now, with all this data, you can see either in Excel or in a PDF file or in a simple text file. So let's see what simple text file looks like. The simple text file looks like this. So all the data, all the outputs and inputs are all put together, and you can print this if you want to. The next thing is the same thing. You can store it in a PDF file. You just click this and it comes out with a PDF file, which looks like that. And this is the total view of that. And then the other thing that you can do is you can do an Excel spreadsheet. You can click this button and then you'll be able to see the Excel spreadsheet, which looks like this. The same data input as well as output. So you can take this data, and if you want to plot your own graph plots, you can do that. So that's primarily the analysis part of it and the report. The next comes the property data. The property data, there are 3 different property data that you can see. One is refractory data. The refractory data, there are many refractory that has been already existing in the program, but you can either edit or create a new one if you want to. Similarly, the fuel, you can do you can create your own fuel, both gaseous as well as liquid fuel. Finally, there is material data. There are 26 different types of steel that we have already entered the data. And right now, you don't have the provision to enter more data because the data, there are extensive data right here. So that constitutes the program, and this is all about our reheat furnace application. So if you need more, if you want to know more about it, you can always give us a call and we'll be able to tell you more about it.